Have you ever, stopped to think that
Wow.
the atoms that make up your hand
Yeah.
might once have been, part of a star
Oh, yeah.
billions of years ago?
Absolutely.
We're going to dive deep into that
Oh.
today. The origins of the elements that make us up.
It's pretty amazing. It is a journey
Yeah.
that spans unimaginable stretches of
Yeah.
time and space from the
Right.
Big Bang
Okay.
to the depths of ancient oceans.
Real.
It's a story that just shows how connected we are to the universe.
So where do we even begin with this cosmic recipe?
We have to start at the very beginning with the Big Bang.
Okay.
Imagine the universe
Yeah.
packed into a tiny point,
Like smaller than an atom.
smaller than an atom,
Wow.
suddenly bursting forth
Okay.
in an unimaginable explosion.
Wow.
That's the Big Bang.
So that's like the universe's birthday party.
That's the universe's birthday party about 13.8 billion years ago.
Wow. Okay. So the Big Bang kind of sets the stage.
Sets the stage.
What happens next?
All right, so out of that primordial soup of energy, the very first element emerged.
Okay.
Hydrogen,
Okay.
the simplest,
Right.
most abundant element in the universe.
Okay.
And it plays a starring role in our story.
So hydrogen is just floating around in the early universe.
That's
How did
true.
it get to be part of me?
So think about early Earth,
Okay.
a hot volcanic world,
Okay.
constantly bombarded by debris from the early solar system.
Right.
That hydrogen,
Yeah.
drawn by Earth's gravity,
Mm.
combined with oxygen
Yeah.
to form something crucial.
Okay. What's that?
Water.
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 So the water we drink,
Yeah.
that essential ingredient for life,
The essential ingredient for life.
traces back to hydrogen from the Big Bang.
Precisely.
That's mind-boggling.
It is mind-boggling, isn't it?
Yeah.
But the story doesn't stop there. We need more than just hydrogen and oxygen.
To build a human.
To build a human,
Right.
that's where things get really interesting
Okay.
and explosive.
Here's where it gets really interesting.
Yes.
What happens next?
Enter stars.
Okay.
These fiery giants
Yeah.
aren't just twinkling points of light.
Right.
They're massive
Yeah.
cosmic furnaces,
Okay.
constantly churning and burning,
Okay.
creating new elements in their cores.
So they're like giant element factories.
They're like giant element factories.
Wow.
Yeah.
So how do stars make elements?
It all comes down to a process called nuclear fusion. Imagine
Yeah.
the immense pressure
Right.
and heat
At the heart of a star.
at the heart of a star,
Yeah.
so intense that it forces atoms to fuse together,
Okay.
creating heavier elements.
Okay.
Stars start by fusing hydrogen into helium, then helium into carbon,
Wow.
and so on,
Okay.
building up the periodic table.
So they're literally creating the building blocks of matter.
Literally creating the building blocks of matter.
That's incredible.
But here's the catch.
Mm-hmm.
Those elements are trapped inside the star's core.
Oh.
How do they get out
Right.
to eventually become part of us?
Yeah. How does that happen?
That's where supernovae come in.
Supernovae.
Yeah.
I've heard that term.
You've heard the term.
I'm not quite sure what it means.
Imagine a star
Okay.
much more massive than our sun,
Okay.
nearing the end of its life.
Right.
It's like a cosmic pressure cooker that's been building up
Yeah.
for millions of years.
Okay.
Suddenly, it can't sustain itself anymore, and it collapses in on itself,
Oh.
triggering a massive explosion,
Okay.
a supernova.
Wow. That sounds dramatic.
It's one of the most violent events in the universe.
Really?
The star blasts its outer layers into space,
Okay.
scattering the newly formed elements.
Mm.
It's been cooking up for eons,
Okay.
carbon, oxygen,
Hmm.
even heavier elements like iron across vast distances.
Hold on.
Yeah.
So the oxygen we breathe,
Right.
the carbon that makes up our very cells,
Uh-huh.
those were once part of a star that exploded millions of years ago. Maybe billions of years ago.
Maybe billions of years ago.
Wow.
It's a mind-boggling concept, but it's true.
Yeah.
Those elements,
Right.
forged in the heart of a dying star,
Wow.
traveled across space
Okay.
for unimaginable stretches of time
Wow.
before eventually becoming part of our planet and
Mm.
ultimately,
Yeah. So we've got hydrogen from the Big Bang,
right.
and then elements like oxygen and carbon from supernovae.
Yes.
What other cosmic players contributed to our elemental makeup?
Well, not all stars go out with a bang.
Okay.
Smaller stars, like
Yeah.
the ones that eventually formed nitrogen.
Okay.
A key ingredient in our DNA and atmosphere have a gentler end.
Okay.
They slowly puff off their outer layers, releasing elements into space.
Okay.
It's like a cosmic exhale, seeding the universe with the ingredients for life.
So hydrogen from the Big Bang,
Yeah.
oxygen, carbon, and heavier elements from supernovae,
Yes.
and nitrogen from smaller stars.
Yes.
That's quite a diverse set of origins already.
That is.
But I have a feeling there's more to the story.
You're absolutely right.
Okay.
While we are indeed made of stardust,
Right.
it wasn't just a passive delivery of elements to Earth.
Okay.
Our planet played a dynamic role
Really?
in shaping and concentrating those elements,
Okay.
turning them into the building blocks of life.
So Earth itself was a part of this process.
Think of early Earth
Aye.
as a giant fiery melting pot.
Hmm.
Volcanoes erupted,
Right.
spewing molten rock and gases,
Okay.
releasing elements like sulfur, which
Wow.
was essential for early life forms,
Okay.
and carbon,
Yeah.
contributing even more to the building blocks of life.
So volcanoes,
Volcanoes.
those fiery, destructive forces,
Yes.
were actually contributing to the creation of life.
It's a reminder that destruction and creation are often intertwined in the universe's grand scheme.
Okay.
And it's not just volcanoes.
What else?
Ancient oceans also played a crucial role.
Oh, really?
They dissolved elements like sodium,
Okay.
essential for nerve signals,
Right.
and calcium,
Okay.
which built up from the shells and skeletons of ancient marine creatures.
Wait, so the calcium that makes up our bones
Yes.
might have once been part of ancient seashells.
It really highlights the incredible interconnectedness of it all,
Wow.
but we're not done yet.
Oh, there's more.
There's another fascinating piece of this cosmic puzzle.
Okay.
We need to explore
Okay.
the role of asteroids and comets.
Asteroids and comets.
Those chunks of rock and ice that
Yeah.
zip around the solar system.
Right.
They acted like cosmic delivery trucks,
Okay.
bringing in even more crucial ingredients to early Earth.
What kind of ingredients are we talking about here?
Well, remember phosphorus? That element that's essential for DNA and cellular energy?
Yeah.
We didn't get much of that from the Big Bang or even supernovae.
Okay.
Instead, a leading theory suggests that much of Earth's phosphorus came from meteorites, those space rocks that bombarded the early Earth.
So we've got elements from the Big Bang,
Yeah.
from stars, both big and small,
Yes.
from volcanoes and oceans,
Wow.
and even delivered by asteroids and comets.
That's right.
It's like Earth was gathering ingredients from all corners of the cosmos.
It's a truly humbling thought, isn't it?
Yeah.
But there's one last
Okay.
mind-boggling ingredient
Really?
to add to our cosmic recipe.
Okay.
Something even more powerful
Oh, wow.
than supernovae.
What could be more powerful than a supernova?
Well,
What's this final element of our cosmic recipe?
imagine two neutron stars,
Okay.
the incredibly dense remnants of massive stars
Okay.
locked in a gravitational dance. As they spiral closer and closer, the energy builds until they finally collide
Wow.
in a cataclysmic event
Really?
that ripples through the fabric of space-time.
Neutron star collisions.
Yes.
I'm trying to wrap my head around the scale of that.
It's about as extreme as it gets in the universe.
It sounds more like something out of a superhero movie than reality.
The energy released in that split second
Yeah.
is more than our sun will produce in its entire lifetime.
Really?
And it's in these cosmic firestorms that some of the heaviest elements, like gold and platinum,
Wow.
are forged.
So the gold in my wedding ring
Yes.
was created in a collision of neutron stars billions of years ago.
It is, isn't it?
That's just wow.
But it's not just precious metals.
What else?
These collisions also produce elements like zinc,
Yeah.
which plays a vital role in our immune systems,
Yeah.
helping us fight off disease.
So the zinc that helps keep me healthy
Yeah.
was born in one of the most violent events in the universe.
It speaks to the interconnectedness of everything, the way the grandest events in the cosmos can influence the most intimate details of our lives.
It's a strange thought, but there's a kind of poetry to it, don't you think?
Absolutely.
Okay, we've covered a lot of ground here.
We have.
Hydrogen from the Big Bang,
Right?
elements forged in the hearts of stars and scattered by supernovae,
Yes.
contributions from Earth's own volcanoes and oceans, deliveries from asteroids and comets,
Yes.
and now these mind-boggling neutron star collisions.
That's quite a symphony of cosmic events.
It's hard to keep track of it all.
But remember, it's not just about where these elements came from. It's also about what they do.
Right. How they contribute to making us us.
Exactly.
It feels like we've been focusing on the ingredients list so far.
Yes.
But now it's time to talk about the recipe itself.
Let's take potassium, for example.
Potassium.
It's essential for our nerves and muscles to function properly.
Okay.
And it has a particularly interesting origin story.
Oh, really?
Some potassium was forged in supernovae, but some of it also arises from a completely different process.
Okay, what's that?
Radioactive decay.
Radioactive decay.
Yeah.
I always thought of that as something dangerous.
It might sound alarming, but it's a natural process that's been happening since the beginning of the universe.
Right.
Unstable atoms over time transform into more stable ones.
Right.
And this decay process can actually create new elements, including potassium.
So even within our own bodies,
In a way,
there are atoms transforming.
it speaks to the dynamic nature of matter.
Yeah.
The constant change and evolution that's happening at the most fundamental level. But let's not forget another essential element, one that often gets overlooked.
What's that?
Magnesium.
Magnesium.
Yeah.
I know it's important for our health.
It is.
I take a magnesium supplement sometimes for muscle cramps.
Right.
But I honestly have no idea where it comes from.
Well, magnesium also has its origins in stars. But its journey is a bit more dramatic.
Oh, really?
It was forged in the hearts of massive stars before being flung out into the universe during those spectacular supernova explosions we talked about earlier.
So the magnesium that helps my muscles relax after a workout was once part of a giant star that exploded millions of years ago.
And speaking of stars, let's not forget iron, the element that makes our blood red. And allows it to carry oxygen throughout our bodies. Iron also has its roots in the fiery hearts of dying stars.
So are you telling me that the iron in my blood
It's a mind-bending concept.
was once inside a star?
As stars age, they fuse lighter elements into heavier ones, eventually creating iron. And when those stars reach the end of their lives, they expel vast amounts of iron into space, sometimes through supernovae, sometimes through gentler processes.
So whether it's a massive explosion or a slow, gentle release, stars are constantly seeding the universe with iron.
An element that's essential for life as we know it.
An element that's essential for life.
And some of that iron found its way to Earth, where it played a crucial role in the evolution of life, becoming the central atom in the hemoglobin molecule that carries oxygen in our blood.
And it's not just in our blood, is it?
And it's not just in our blood.
Iron is also a major component of Earth's core.
The early Earth was a molten, chaotic place. As it cooled and solidified, heavier elements like iron sank towards the center, forming the core we know today. And over billions of years, geological processes like volcanic eruptions and erosion have brought some of that iron back to the surface, where it eventually became incorporated into living organisms.
Hold on. Are you saying that the iron in my blood
It certainly
might have once been part of Earth's core?
It's like a giant elemental cycle with atoms traveling from the heart of stars to the depths of our planet and back again.
It's a beautiful illustration of how interconnected everything is.
Precisely. From the smallest atom to the largest celestial body.
Wow.
And remember, we're only scratching the surface here. We've talked about some of the major players. But what about those trace elements? The ones that exist in tiny amounts, but are still crucial for our health. They have equally fascinating origin stories.
You're right.
Absolutely.
We've talked about iron in our blood.
Yes.
But what about, say, the copper that helps our bodies use that iron efficiently?
Copper is crucial for energy transfer in living things. And it's thought to have been slowly built up in aging stars over billions of years. As these stars reached the end of their lives, they gently puffed off their outer layers, releasing copper and other elements into space. Eventually, some of that copper found its way to Earth, becoming incorporated into our planet's crust.
And ultimately into us.
It's amazing to think that something as seemingly simple as copper,
and it's not just copper,
has such a long and complex history.
There are countless other trace elements with equally fascinating origins. For example, selenium, which is essential for a healthy immune system, is thought to have been produced in stars and then scattered by supernovae. It eventually made its way into the soil and plants, entering the food chain and becoming part of us.
So from exploded stars to the food we eat, it's all connected.
It's a humbling thought for sure.
Yeah.
And it's a reminder that the story of the elements is not just a story of stars and galaxies. It's also a story of life itself, of how life has shaped and been shaped by the elements that make it up.
Speaking of life's role in this cosmic story.
Absolutely.
We've talked a lot about how elements arrived on Earth.
Yes.
But I'm curious about how early life forms themselves.
Might have influenced the elemental makeup of our planet.
Life has been a powerful force in shaping our planet. And that includes influencing the distribution and abundance of certain elements. A prime example is the very air we breathe.
Oxygen. So we know oxygen was produced in stars.
Yes.
And delivered to Earth through supernovae.
Right.
But I've always wondered how early Earth...
That's where life comes in.
Which didn't have much oxygen to begin with.
The earliest life forms on Earth were simple single-celled organisms.
Right.
Some of them developed the remarkable ability to photosynthesize.
Photosynthesis.
Exactly.
That process where plants use sunlight to create energy.
Yes.
And release oxygen as a byproduct.
And as those early organisms went about their business, photosynthesizing away, they gradually transformed Earth's atmosphere, pumping out oxygen and creating the oxygen-rich environment we depend on today.
So the air we breathe.
It really is.
The very breath of life.
Life has played a profound role.
Is thanks to the ingenuity of ancient bacteria.
In shaping our planet.
It's just, wow.
Even at the elemental level, it's a reminder that the story of the elements is not just a story of cosmic events. It's also a story of life itself, of how life has shaped and been shaped by the elements that make it up.
It's a beautiful and intricate story.
We have.
But I feel like we've only just begun to explore its depths.
There's so much more to uncover. So many more mysteries to unravel. But for now, let's take a moment to appreciate the incredible journey we've been on.
Okay.
Our journey that's taken us from the Big Bang to the very essence of what makes us human.
It really is incredible to think about how all these elements, from hydrogen forged in the Big Bang, to heavier elements created in supernovae, all came together to form us.
It's a testament to the interconnectedness of the universe. How everything is linked in this grand cosmic web.
And we've only just scratched the surface of this amazing story. There are so many more elements.
There are.
With their own unique origins. Each playing a crucial role. In this intricate tapestry of life.
Take iodine, for example.
Iodine.
It's vital for thyroid function, which regulates our metabolism. And you know where it came from.
Where did it come from?
Violent star explosion. Similar to supernovae.
So even the tiniest amounts of elements in our bodies.
It's fascinating.
You have these grand cosmic backstories. That's fascinating.
Tell me more about these trace elements. What other stories are there?
Well, there's selenium.
Selenium, yes.
Which is another element essential for human health.
It's thought to have been produced in stars and then scattered by supernovae. It eventually made its way into the soil and plants, entering the food chain and becoming part of us.
So from exploded stars to the food we eat, it's all connected.
It is.
What else?
What else?
Are there any more examples
absolutely.
of these fascinating trace element origins?
Let's talk about fluorine.
Fluorine.
You know, the element that helps strengthen our teeth?
Right.
I never would have guessed.
I never would have guessed either.
It had a cosmic origin story. Well, it's believed that fluorine likely formed when helium and hydrogen interacted in stars. It then became incorporated into Earth's minerals and ultimately found its way into our bodies.
This is mind-blowing to think about.
It really highlights the point.
The intricate web of connections.
That we are not separate from the universe. We are a part of it. Literally made from the same stuff as stars, planets, and everything in between.
You know, after this deep dive...
It's a profound shift in perspective.
I don't think I'll ever look at myself the same way again.
And it raises so many questions.
It's both humbling and awe-inspiring.
What other secrets does the universe hold?
To realize that we're not just observers of the universe.
What other wonders are hidden within us? Waiting to be discovered.
Those are questions worth pondering.
They are.
I think this deep dive has given us a lot to think about.
It has.
Not just about the science.
It's a reminder that we're part of something much larger than ourselves.
but also about our place in the grand scheme of things.
Connected to the cosmos in ways we're only beginning to understand.
So the next time you look at your hand, think about the incredible journey those atoms took.
A journey billions of years in the making.
Billions of years in the making to become part of you.
We are quite literally made of stardust.
We are quite literally made of stardust.
Testament to the power, beauty, and interconnectedness of the universe.
And who knows what other cosmic wonders are hidden within us.
Exactly.
Waiting to be uncovered.
Yeah.